So today we're going to talk a little bit about the basics of logarithms. Many of you have had a little bit of exposure to logarithms in your previous math experience. They are inverses of exponents, so they kind of undo an exponent. But many of you are a little bit nervous when you see that word logarithm because you don't have enough experience with it to feel comfortable. So we're going to try to handle that today. So the first thing we're going to look at is actually evaluating an exponential expression. So we're going to look at an exponential expression, and the one we're going to look at is, let's see if we can write it down so those of you who don't have the notes in front of you can see it. So the expression is going to be f of x is equal to 13.55 times 1.33 raised to the x minus 7. Okay, and so this is kind of what it looks like. We want to know how to evaluate this thing at a specific value. And so just like any other, let's see, we'll do it this way. Just like any other function, if you are asked to evaluate, let's say, f of 5. What is f of 5? Well, f of 5 would be, I'm gonna learn how to do this. It's backwards on my screen, so bear with me. Do you see that the 5, see the 5? 5 replaced the x. I'll have to look down, I guess. 5 replaced the x here, so that in this expression, 5 would also have to replace the x. So we get our handy-dandy calculator out, and we punch in 13.55. So let's do that here. 13 helps to turn it on. Clear. 13.55. And let's see, times 1.33 raised to the 5th power, because 5 is replacing the x there. And then we're going to subtract 7. Okay, we're going to just see what our calculator, let's see, bring this in here so you can see it. Yep. See what our calculator comes up with, and it comes up with this value 49.3894 ... Okay, so we can say that f of 5 is, and I think that the instructions on this page says round to the 3 decimal places, so 49.389. Okay. All right. So then what if I asked you to do something like this? F of E. Now this is something that may be new to you. F of E. E is actually a number, and it's kind of like pi in that it's really special, and it's considered irrational. So it's not a variable. That's the one thing you need to remember, is E is not a variable. But we can use our calculators to, again, take this function and where we see the x, replace it with E. So let's come over to our calculator here. And if you're using a TI, E is found in a couple of different places. If you just want the value E, it is the yellow button above your division symbol. But if you're going to take E and raise it to a power, which we often do, that's a handy thing, you'll find it right over the ln key right here. So I'm going to use this handy-dandy trick of doing second entry. So that's going to pull the last entry that I did on my calculator. Oh, here you go. And then I'm just going to go back to where I put the 5 in. I'm going to cursor backwards over here and put the E in right there. Okay, and you see that instead of having to type the whole thing out again, I just replaced the one thing that I needed with E and press enter, and I get my answer. 22.417. 22.417. Okay, so I think the last thing that we have on this part of the notes is to be able to do something like this, 5 to the negative 2.5. And it's kind of mixed in there with those function problems, but you notice that there is no function notation. That means that I don't use the function that's defined at all. I just punch what I have here, 5 raised to the negative 2.5. And the whole problem, or the whole reason for this problem is to help you understand that we can have negative exponents, we can have fractional exponents. Our exponents don't have to be whole numbers, which is what we're used to dealing with, but we don't have to have those as our exponents. So we can go ahead and crunch that, and we get a number of 0.01. In this case, since we're rounding to the third decimal place, we'd say 0.018. Okay, so 0.018. Okay, there we go. All right, so now we kind of get into the meat of what this lesson is about, which is what are logarithms. And when we're talking about logarithms, like I alluded to before, we have to think about them as things that undo exponents. And so first we're going to define the logarithm. So I'm going to come over here and I'm going to define the logarithm for you. So if we have this thing, log base b of x is equal to y. This is a logarithmic equation. Okay, it is exactly the same as saying b raised to the y power is equal to x. These are equivalent statements, okay? So if you have something that's written in as an exponential equation, it can be written as a logarithmic equation and vice versa. And that is a really good skill to know, is taking a logarithmic equation and writing it as exponential, and taking an exponential equation and writing it as a logarithmic equation. Now, these three conditions must apply, and this one in particular is one you want to pay a lot of attention to. Notice that x must be positive. That means that this argument of the logarithm has to be positive. We cannot take a logarithm of 0, nor can we take a logarithm of something negative. Try it in your calculator. Your calculator will spit you back an error. You just can't do it, okay? And that's because if you think about it, if I take any number and raise it to any power, will I ever get 0 out? No, okay? As long as that base is not 0, and your base is not 1, well, that wouldn't affect the 0 thing. But you're never going to get a 0 or something negative out. So this is really important. Also, keep in mind that our bases have got to be positive, base here, and your base cannot be 1. And the reason that why our base can't be 1 is because you think about 1 raised to any power, you're always going to get a 1 out, and that is not an exponential function nor a logarithmic function. So this is your definition. So as I kind of talked about before, it's really nice to be able to take something like this and write it like this and vice versa. So that's the first skill we are going to look at. We are going to look at, let me see if I can find where I wrote these. This one, okay. Log base b of x is equal to y. We're going to take this thing and rewrite it as an exponential equation. And we're going to do that with these examples. So I want you to take a second and internalize this. When you take something that's written in logarithmic form and you're going to rewrite it as an exponent, you're always going to start with the base. The base of the log is where you start. So we're going to start with b. Okay, so we're going to start with a b. So here we're starting with b. And we're going to cross equal sign b raised to the y power. Okay, b, start with the base, raise it to the y power, come back over the equal sign is equal to x. Okay, so here we go. b raised to the y power is equal to x. So we're going to take these equations here and we're going to do the same thing. All right, so starting with this example. What's the base? Here is the equation. Log base 6 of 216 is equal to y. What is the base here? The base is 6, so that's where we start. 6. Now 6, what do we do next? We have to cross the equal sign. 6 raised to the y power. Okay, so 6 raised to the y power. And then we come back across, is equal to 216. Okay, so at this point, I would encourage you to take a second and pause the video and see if you can rewrite these next two equations on your own. All right, and then pick it back up and see if you've done them correctly. Okay, so pause, try, and come back in a second. Okay, hopefully you came back and you're able to check your work. Again, here we start with the base. B to the third is equal to 27. So this one is b cubed is equal to 27. All right, and the last one we have, let's see, 9 is the base, so 9 squared is equal to x. Okay. 9 squared is equal to x. Okay, so this is being able to rewrite something that's in logarithmic form as an exponential equation. Really good skill to have. Okay, so now we want to go ahead and check and see if we can do it the other way. And for some reason, this seems to be more troublesome for students. So notice that here I have an exponential equation. We want to rewrite it as a logarithmic equation. And here's 3 examples. Again, start with the base. If I want to take something in exponential form and rewrite it in logarithmic form, I'm going to start with the base. Log base b. Our base is b. So starting with the base, we have log base b. Log base b. Now I'm going to cross that equal sign and then come back. Log base b of x is equal to, and we come back to y. Log base b of x is equal to y. Okay, so go ahead and let's take a look at that first example. 5 to the 4th power is equal to 625. Start by identifying the base. What is the base of this exponent? The base is 5. So we're going to say log base 5 of what? Oh, that's where you cross the equal sign. Log base 5 of 625. And what is that equal to? Well, that is equal to 4. Fantastic. Okay, here again, I'm going to invite you to pause your video right here and try to write these last 2 equations as logarithms. Okay, and come on back and check these out. Make sure that you have them correct. Log base 2 of 1 over 32 is equal to -5. Log base 64 of 4 is equal to 1/3. Okay, so here we go. And you're looking at me on the second one going, yeah, I get that. And the third one, you're saying, oh, not sure where she got that from. Okay, and so that leads us into the next thing we need to kind of remember is sometimes we have forgotten some of the rules of exponents, and it's a good idea to kind of just remember, review, revisit these things because they do rear their heads when we're talking about logarithms, because logarithms and exponents are so closely related. So x to the -1. This, whenever we have a negative exponent, remember that pulls the base down into the denominator. If it's in the denominator already, it's going to flip it up to the numerator. So if I am looking at x to the -1 power, that is the same as saying 1 over x, or 1 over x to the first. And of course, if it's the first power, we don't need to write the first power. Okay, so how about x to the negative a power? Well, I'm going to take that and flip it and make that 1 over x to the a power. Notice that the base of the exponent just goes down to the denominator. The exponent goes down to the denominator, but now I've lost that negative exponent, okay, which is a nice thing. Nobody really likes the negative exponent thing. Okay, so now let's look at x to the 1/2 power and x to the 1/3 power, x to the 1 over n power. These are all fractional exponents, and fractional exponents are also known as radicals. So you may or may not remember that, but when you have something to the 1/2 power, it's the same as the square root. So x to the 1/2 power is the same as the square root of x. Right? And though we can write that index of 2 right in there, you know, we typically don't. It's not wrong, just not necessary. Okay, so then using that as a model, you could probably deduce that x to the 1/3 power is the cube root of x, and that's where you take that 3 and you make it the index of your radical. Fantastic. So using these things, you could probably come up with x to the 1 over n power, which would be the nth root of x. There we go. Okay, so these kind of rules that we haven't probably used for a little while are good to remember, recall, because we are going to be able to, well, we're going to need to know them, okay? So some of the logarithms we're going to be dealing with will also deal with those kind of rules. So the next skill that we're going to look at building with you is how to evaluate a logarithm without using your calculator. Just like you should be able to do simple multiplication, simple exponents without using that calculator, you should be able to evaluate simple logarithms without a calculator as well. One of the techniques you can use is if you have a logarithmic expression, log base something of something, and we want to know what that equals. Well, if you take your argument of the logarithm and rewrite it as a power of the base of the logarithm, then the log is equal to whatever the exponent is. Okay, for example, log base 2 of 8. If I take that 8 and rewrite it as a power of 2, then whatever that power is what the log is equal to. The log is asking you what is the power of the base. Okay, so log base 2 of 8, 2 to what power is 8? Well, that's 2 to the 3rd power, so the logarithm would be 3. So let's practice these for a little bit, okay? So we're going to use this technique of trying to rewrite our arguments as powers of the base. Okay, so we're going to start with some things that are fairly easy. Log base 8 of 64. Okay, so what I want to think about is how can I write 64 so that it is a power of 8? Okay, and you probably know that right off the top of your head. Well, that's the same as log base 8 of 8 squared. Okay, so now if you can write it so that your power, the base of the log and the base of this exponent are the same thing, well then what you're left with here is your answer. So log base 8 of 8 squared is equal to 2. Okay, so fantastic, yippee skippy here. Let's look at log base 6 of 1 over 6. Okay, now that's where one of those properties of exponents come in, and let me think about this for a second. If it was a fraction, that was a negative exponent, right? Okay, so this is the same as log base 6 of 6 to the negative 1, which, okay, so if you got the power, the base of the log, the base of the exponent matching, then my exponent is my answer, and that gives me a logarithm of -1. Log is equal to -1. Sorry. All right. Last one of these here, log base 6 of the square root of 6. Take that radical and rewrite it as a fractional exponent. Log base 6 of 6 to the what? Okay, that would be log base 6 of 6 to the 1/2 power. Now we have matching bases. The log base and the exponent base are the same, and so we can say that our answer is just 1/2. Fantastic. Okay, so now we're going to make it a little trickier. Okay, not terribly tricky, but it's going to require you to think a little bit harder. Okay, so let's look at these. Log base 81 of 9. So I want to write this argument as 81 to some power. Now, if the numbers were flipped, it'd be really easy, right? If this was log base 9 of 81, well, what do you do to 9 to make it 81? You do what? Oh yeah, you square it, right? So you square it to go from 9 to 81. So what does that imply if you go from 81 to 9? That means you're taking the square root, right? So let's say log base 81 of the square root of 81. Isn't that the same thing? Yeah, right? And now we can write it as an exponent. This is log base 81 of 81 to what power? 1/2 power. And so this is all equal to 1/2. Okay. Very good. Okay, so now let's think about this next one. Log base 3 of 1/9. 1/9. Okay, we want to get the 3 in here somehow. Okay, well, let's think about just replacing that 9 with the power of 3. Couldn't we say that that is the same as log base 3 of 1/3 squared? Yeah? Okay, but I don't want it as 1/3 squared. I want it as just 3 to some power. Okay, and that's where we use those negative exponents. So this is the same as log base 3 of 3 to the negative 2, and so our answer is -2. Okay, good deal. All right, a couple that are a little bit more intricate. We're going to look at this one, which looks really scary, but now that you've done a few of these, it's really not so bad. I think that I use this as a verbal example. Log base 2 of 8. Well, think about this. 2 to what power is 8? 2 to the 3rd power is 8. Okay, so that whole thing is equivalent to 3. How about log base 5 of 25? Think about this. 5 to what power is 25? 5 to 2nd power. 5 squared equals 25. So this expression, log base 2 of 8 plus log base 5 of 25, is the same as asking you what is 3 plus 2. Which you know is 5. Great. Now something like this, where you have a nested logarithm, log base 2 of log base 3 of 81. Just like in PEMDAS, we're going to tackle everything within the parentheses first. We're not going to worry about anything on the outside, just what is inside. Okay, so let's think about what is log base 3 of 81. Log base 3 of 81. Okay, 3 to what power is 81? 3 times 3 gives me 9, times 3 again gives me 27. That's to the 3rd power. 27 times 3 gives me 81. Oh, good. So that's 27 times 3, which would be 3 to the 4th power. So log base 3 of 81, that's the same as just 4. So log base 2 of 4. Okay, because that log base 3 of 81 equivalent to 4. So I can just replace that whole thing with 4. Now I'm going to evaluate this part. Log base 2 of 4. 2 to what power gives me 4? You know this answer. The answer is 2. So this whole thing is 2. All right, last example, and we call this a day. Let me see if I can find it. It's a little bit special, so we want to make sure that we do look at it. It's this one. Log base 2 of 1/8 I'm sorry, log base 3 of log base 2 of 1/8. All right. So for this one, we're going to look at 2 to what power gives me 1/8? Well, 2 to what power gives me 8? You know that. That's 3, right? But to bring it to the denominator, we need something negative. So this would be 2 to the negative 3rd power would be 1/8. So this whole thing, log base 3 of -3. Okay. And so we want to evaluate this. Log base 3 of -3. Now here we run into an issue. And the issue comes from some of those, let's see if I can find, this thing. Remember, x must be greater than 0. Our argument must be positive. And what are we trying to take a logarithm of here? We're trying to take a logarithm of something negative here. So log base 3 of -3, there's no solution here. So you can say this is undefined or just null set or no solution, whatever your instructor wants you to do here. Your calculator, if you were able to do this in your calculator, would say, oops, error. Yeah, so it's mathematically impossible to calculate. All right, so that wraps up this lesson on basics of logarithms. When we pick up in class next time, we will be talking about properties of logarithms. So until then, ciao.